Okay, now let's talk about common data science tasks. And in fact, oftentimes, most of what a data scientist can do can be boiled down into one of these common data science tasks. In a future lecture, we're actually going to go through exactly what these things are and how they're done. But for now, I just want to give you some examples to start getting your brain working so you understand what these tasks are like. A first example that I'm going to show you is customer segmentation. This is done using oftentimes a clustering algorithm. Now, customer segmentation, if you're not familiar, is where you take your existing customer records and you actually create oftentimes what's called personas. You want to figure out how can I group my customers together so that I can learn about them on a larger scale by creating basically categories of customers. Oftentimes this in the old days was done by hand. So you would actually imagine yourself saying, well, there's a 25 to 30-year-old family with one child, and that would be one of your personas. Today, we don't have to do something like that. We can actually let the algorithm do it for us. So we can say, hey, algorithm, here's all of our data. Can you cluster these in some way that makes sense? Now, the trick with clustering is that it doesn't always work the way you want it to. But also the good thing about clustering is you can just do it again until you find the match that you like. And we'll talk about again how this is actually done in a later week. But for now, this is that example. There's another common data science task called association mining. This is also clustering. Association mining is where you find two things or more things that are actually associated to each other. The obvious example of this is in grocery stores. Grocery stores do this quite often with their products. They will ask the question, what kind of products are commonly bought together? So for example, if you are CU or Circle K here in Ulaanbaatar, you might ask, well, what do you normally buy with a hot dog? And you probably have a good bet that it's a Coke, but you don't necessarily know, and so you can actually have the clustering algorithm determine this for you. By understanding what customers buy together, you can start to then create better marketing tools, advertising techniques, or promotional campaigns to actually get people to buy these things in a different way or more of them. The other thing you might want to do is start to understand how people are buying things together that you don't normally think about, so you can change the layout of your physical store or your virtual store, if you have a virtual store, in order to get customers to buy these things together. The next one is called anomaly or outlier detection. This is a really fascinating field because algorithms are in fact really good at finding things that don't belong. The most famous case of this is in fraud detection for banks. If you go to a foreign country, before coronavirus of course, if you were to go to a foreign country and you were to swipe your Visa card, and the bank might then say, hey, this transaction is coming from a different country. This maybe looks suspicious. Maybe we should call them to verify that this is actually a real transaction. This is a simple form of anomaly or outlier detection. You could also use anomaly or outlier detection to find fraud in financial statements, to perform audits, to find potential criminal activity in a company, and of course fraud. There's other classification tasks that are really common that you might have even seen or used in your daily life. One is spam email. So what is a classification task with spam specifically? A classification task simply says, what category does this data belong to? Spam classification or detection is a really simple example of this, where the computer algorithm has to ask, is this spam? Yes or no. Is this a good email? Yes or no, basically. Now, if it is spam, of course, it gets kicked over to your spam folder and you probably don't see it. And these algorithms actually work really well today. And that's one of the things that we can be thankful for with these classification algorithms. Another one that you may or may not appreciate is something called loan approvals or denials. This is, again, where it's a simple question of, should this loan be approved, yes or no? Now, all classification tasks are not binary. They're not a yes or no question. Oftentimes, you can have what's called a multi-class classification problem. This is where you're actually trying to put the data into multiple categories. The very famous and simple example that we always go through very first when we talk about machine learning is the iris dataset. This is where you get specific measurements about flowers, and you try to figure out what kind of flower it is based on the input data. And it's really as simple as that. It's important to remember here that out of all of the tasks above, data scientists at the core are actually just making predictions. We don't always know what something is. We have to predict what something is based on the given data. And of course, it's important that our predictions are actually accurate, and that's one of the reasons why we have to test them well. Okay, let's take a look at this quote for a second, because I believe it's important. If a human expert can easily create a pattern in his or her own mind, it is generally not worth the time and effort of using data science to discover it. If you had a simple question like, what color is this? Red, green, or blue? It doesn't really make much sense to have an algorithm do that, because it's very rare that you would actually need this to be done, because humans are very good at it. We do not have a problem of trying to pick different colors out, unless perhaps you're colorblind, but that's a very small portion of the population. So what does this really mean? Well, to put simply, a lot of people ask me, wouldn't it be cool if we could do this? Or wouldn't it be cool if we could do that with data science? And sometimes I say, well, yeah, it would actually be really cool, but what's the value in it? Does it actually make sense for a data scientist to spend time working on this problem? As it is in the world today, there probably aren't enough data scientists. And data scientists, even in the economy that we have today, are in still very high demand. And so should data scientists be wasting time on problems that are very easy to do, or problems that are not actually very useful? And the answer is, of course, no. So it is important to remember that just because something is possible doesn't mean that you should do it. Let's now briefly discuss, well, human limits. Before we discussed a simple example of, can I pick red, green, or blue out of a picture? And of course, yes, we can. But what if it was more than that? So put simply, humans can see patterns, and making rules with 2 or 3 things, and this is called features or variables, we're very good at this. So again, let's take the color example. If I give you a picture and there's either red, blue, or green in the picture, and I ask you what color is in the picture. And it's really simple. You just look at the picture and you pick the color. Now, the actual color is called a variable or a feature in this data set. But what if you had tens of pictures, or hundreds of pictures, or thousands of pictures? Or what if you had more than just one color? What if the question were more complicated? What colors in the picture? What objects are in their picture? And then how is this changing over time, say, for example, in a movie? Now we're getting to the limits of humans. Humans are not actually very good at doing these kinds of things on a large scale. We can oftentimes answer these questions really simply if it's just a small data set. Another example that I might give you is about accounting. If you know anything about accounting, you know that you have these transaction records and you also have like financial statements. Now, it's not that difficult to actually look at a financial statement and interpret it for a human. But what if you wanted to evaluate all of the transactions of a company if you were doing an audit? Well, that's a lot of data. And imagine if it's a medium-sized or a large-sized company. You might be talking about thousands or hundreds of thousands of transactions. Does it make sense for a human to go through those by hand to check them? Not really. And this is where data science can actually step in. Whereas individually the task might be simple, but at some point you're going to hit the limits of humanity. And this is where data science actually becomes useful. So let's talk about a very specific example, what's called churn in a business. And if you don't know what churn is, well, basically churn is where a customer enters a company, and then they stay with the company for some period of time, and then they leave the company. Oftentimes, this is on a recurring basis, so something like a phone plan or an internet service provider contract or something like that. These are the common use cases for this. So company A, in this case, wants to make a customer churn prediction model. And what this means is they want to figure out when a customer is going to leave the company. They already have the customer, it's already their customer, but they want to figure out, hey, which of our customers is about to quit our service or product and move to a competitor. Now, several questions need to be asked before you actually make this model. And the most important question you should ask is, how can I make this model useful? Just because I find someone who's about to leave the company doesn't actually mean that it's going to be useful. So let's put this in a better perspective. Number one, the model needs to generate actionable insights. This basically means that if the model says this person is going to leave the company, one of the things that would be helpful for the model to say is why. Why is this customer unhappy and why do they want to leave? Is it because of poor customer service? Is it because of product problems? Maybe they've had to call support oftentimes, or is it some other reason? And this model hopefully will give you some actionable insights so that you can actually go to the customer and if you want to keep them, take some action. Number two, the model needs to identify the customers early enough to contact them. If the model says, hey, this customer is going to leave the company tomorrow, is that early enough? Oftentimes, no. People are busy. What if you are Univision or Mobinet or Ulusnet or one of the other many internet service providers in Ulaanbaatar, and your customer churn prediction model says, hey, this customer is about to leave for a competitor. If the model said the person was going to leave yesterday, well, that's not very useful, is it? Because they already left. So you can quickly see how that's the second question that you need to answer. And the third question is, the company can put a team in place to prevent churn. Is the company even capable of having a team to prevent this churn from happening? Oftentimes, companies don't have a customer service team that is able to create an intervention with a customer to say, hey, you're about to leave the company. We don't want you to. Let's see what we can do to keep you. And this is actually something that a company has to think about, and it's not something that companies are by default set up to do. So this is a really simple and common example of how you would actually apply a data science model in a company for the example of churn. It's not as simple or as maybe flashy as a lot of people think, and you really do need to think about the details before you implement this. Okay, in the next video, I'm going to go over a brief history of data science and data analysis.